Okay, you guys. So if you're at this point in the lesson, you have already checked your answers to the ice, liquid, water, turned to steam investigation. I'm in your BP1 packet. And what I mean by that is I posted some good answers to check to. And that would be page 10 and 11 and 12 in your packet. You've already done that. And we're going to take that information, the things that you investigated, the things that you checked your answers to, and we want to get that in our notes section of this same packet. So I want you to turn in your note packet to page 2. Okay, and this table right here reflects this table. And we're going to put this in as some drawings, but then also talk about how the compactness of those molecules relate to its kinetic energy. So for a solid, and remember at any point you can pause this and do a little bit more if you need to with taking time to write it down. But a solid, I really like this picture. It's kind of showing how, and I know that I drew lines with my answer key for you to check, trying to show that they're each bonded together. I like how these are showing they're very close together and they're kind of wiggling or jiggling in place. So I have an example here of a model of a solid, and this would be a crystal solid. But, these things are bonded. These atoms are bonded to each other, but they're also shaking. They're vibrating in place. Okay, if we were able to look at that, and, I'm trying to show the whole thing shaking because those molecules are moving. So that's what we're trying to show with vibration there. Solid kinetic energy would be the lowest. They're not moving around. They don't move as we see as we get to gases. And that reflects their lower temperature. Remember, there's a relationship between kinetic energy and temperature. So ice has a lower temperature as a solid. It doesn't have as much kinetic energy. A good picture of a liquid. It's still confined within a given volume. And in the movement, there's a little bit more movement. So it's gone from a shaking, jiggly type of motion to truly being able to move past one another. This is what makes a liquid appear to flow as they move past one another. And they would be given the middle kinetic energy level. So they have a medium amount, not really low, not very high. They're the middle child. And then gases, they're moving all over. So they're going to go outside of the container. Yes, they can take the shape of the container, but as far as if I wanted to find the volume of a gas, it can be indefinite. It depends on different things, temperatures and pressures and all of those things we've all thought about. And we've all probably taken, like a balloon or something, and you can squeeze a balloon, or you could take a water bottle like this. It's not even all the way full. And I can change that gas that's up above here. I get that there's liquid down here, but the gas that's up above here, I can squeeze on that, and I just now changed the volume. So that's what we mean by indefinite volume, where if this whole thing was full of liquid only, you could try this at home in front of a sink. If you fill a water bottle up all the way with the liquid and you try to squeeze on it, and I truly mean all the way to the top, put the lid on it with the liquid, you won't be able to squeeze it. Where on the other hand, if we take this out, it's really hard to waste good water. So that water costs money. Hold on. Now, I close this up, and I can squeeze on it, right? And I can really change its volume. That's what we mean by a gas having indefinite volume. Okay, try this at home, and you could do all this. I'm being loud. Now, let's fill this up with water, just to show. Water liquid. Before, we could have said that would be water like a vapor. And I know there are other gases in there. But I'm going to try my best to literally get it all the way filled to the top. I'm going to use an old Coke can to do this. And then I will put the lid on this. And again, you guys have fun. Try this at home. And then I try to squeeze on this, and I can tell I can even see that I still have air in here. You can see that water, the air bubble moving, I think. I don't know if you guys can see that coming to the top. But if I had no air in here at all, I can't compress this. What I'm compressing is the leftover gas that's in here. All right. But liquids are not very compressible. And so they have more of a definite shape and a definite volume. They have an indefinite shape. They always take the shape of their container. Same with the gas. Okay. So they are going to have the highest kinetic energy. The very highest. So this is all I need you to fill in with your notes. The rest of what I want you to do, and it's written in your agenda, but in this same packet for homework, I would like for you to do pages 13 and 14. Okay, pages. Actually, I think I'm not gonna have you guys do that until Friday. So I don't think you have any homework. You filled this in? Hold on. You don't have homework. We're gonna do this on Friday. Okay, that's that shortened day. So if you want to jumpstart and get ahead, go for it. Then you won't have any homework for Friday. But I think I'm gonna pause and have you guys do that on Friday. So hope everything's going well. We will talk soon and take care.